Morning, everyone. Welcome to another session today. On data analysis and visualization. Last Monday, we spoke about evaluating a range of predictive analytic techniques to discover new knowledge for forecasting future events. We watched a video on why we use R. We compare a range of predictive analytic techniques for forecasting purposes with example, which includes time series analysis, regression analysis, among others. We also spoke about like each one of them, and we spoke about the Bayesian method. We spoke about the limitations and advantages Bayesian method. We spoke about how to install Anaconda and how to run a Python code, and among other things. So today we'll be looking at demonstrate prescriptive analytic methods for finding the best course of action for a situation. So this will be our last topic on data analysis and visualization. And tomorrow we'll be looking at discussion module about assignment and about assignment discussion. So what are the indicative contents today? First of all, classical optimization, linear programming techniques, nonlinear programming techniques, dynamic programming, models, justifiable decisions, and defensible decisions. So today also we'll be looking at what is prescriptive analytics. Let's open the video down, and after the class, we will finish it. We will continue the video. What is classical optimization? Classical optimization refers to the branch of mathematics that deals with finding the best solution for a given problem within a set of constraints. It involves formulating an objective function and defining constraints, then applying mathematical techniques to determine the optimal values for the decision variables. 2, there are various classical optimization techniques that can be used to solve optimization problems, including linear programming, integer programming, non-linear programming, 4, quadratic programming, 5, mixed integer linear programming, and the last one, convex optimization. So what is linear programming? Linear programming deals with optimizing linear objective functions subject to linear constraints. It is widely used in operational research and management science. LP, also known as linear programming, LP problems can be solved using algorithms such as simplex method or interior point methods. What is integer programming? This type of programming extends linear programming to handle problems with integer decision variable. This is useful when decisions must be made in discrete quantities. Algorithms like branch and bound or branch and cut are commonly used to solve IP problems. What is nonlinear programming? This involves optimizing nonlinear objective functions subject to constraints. NLP problems are more complex than linear programming. Problems require specialized algorithms such as Newton's methods or quasi-Newton methods. Let us Google what Newton. Let us check what Newton methods means. and also quasi-Newton. Over here, you can see what it means, and obviously we can have a look at it in our own free time. And this URL also provides what it means. So just find time to have a look at this. Let's go back to our slides. The next one is quadratic programming, QP. Quadratic programming deals with optimizing quadratic objective functions subject to linear constraints. QP problems have numerous applications, including portfolio optimization and control systems. Algorithms like sequential quadratic programming, SQP method, or interior point methods can be used to solve QP problems. MILP. This combines linear programming with integer programming, allowing for problems with both continuous and discrete decision variables. MILP problems can be solved using techniques like branch and bound algorithm or the cut and branch method. What is convex optimization? This focuses on optimizing convex objective functions subject to convex constraints. Convex optimization problems have desirable properties and efficient algorithms like interior point methods, or subgradient methods are available to solve them. The next subtopic is seem to see clearly. Yeah, evaluate prescriptive analytic techniques with appropriate examples. First of all, prescriptive analytics is a branch of analytics that focuses on determining the best course of action or decision based on available data, constraints, and objectives. It goes beyond descriptive and predictive analytics by providing actionable insights and recommendations. Here are a few prescriptive analytic techniques along with examples. Optimization model. The first one is optimization model. The second one is decision trees. Third, simulation. Fourth, game theory, linear programming, and the last one, prescriptive machine learning. So the first one, which is optimization models, this helps find the best solution given a set of constraints and objectives. For example, a logistics company can use optimization techniques to determine the most efficient routes for delivering packages, considering factors such as traffic, distance, and delivery time windows. Decision trees. These are used to map out decision-making process by considering various possible outcomes and associated probabilities. For instance, a bank can use decision trees to evaluate credit worthiness of loan applicants based on factors like income, credit history, and employment status. Simulation techniques. These techniques are employed to model real-world scenarios and observe the impact of different decisions or actions. For instance, a manufacturing company can simulate production process to determine the optimal allocation of resources and identify potential bottlenecks. What is game theory? Game theory is used to analyze strategic interactions between multiple parties and identify optimal decisions. For example, in the telecommunication industry, game theory can be applied to determine the best pricing strategy for competing companies based on market conditions and competitor behavior. The next one is linear programming. This is a mathematical technique used to optimize a linear objective function given linear constraints. For instance, a farmer can use linear programming to determine the optimal allocation of resources, e.g., example, land, labor, fertilizers, to maximize crop yield while minimizing costs. The last one, which is prescriptive machine learning. This combines predictive analytics with optimization techniques to provide prescriptive recommendations. For example, an e-commerce company can use machine learning algorithms to predict customer behavior and then optimize product recommendations to maximize sales and customer satisfaction. Our next subtopic is apply an appropriate programming language or tool to demonstrate how these prescriptive analytic techniques are used to find the best course of action in a situation. First of all, the first example, consider a manufacturing company that produces two products, product A and B. The company has limited resources such as labor hours and raw materials and wants to determine the optimal production quantities of each product to maximize profit. The profit per unit and resources requirement for each product are as follows. 1. Product A, profit per unit, $10. Labor hours per unit, labor hours per unit, 2. Raw material units per unit, 3. Product B, profit per unit is $15. Labor hours per unit is 4. Raw material units per unit is 5. So the company has 100 labor hours and 120 raw material units available. We can use linear programming to find the optimal production quantities of each product that maximize the total profit. Here is an example. So we are going to look at an example of Python code that uses the pulp library to solve this optimization problem. So this is it. So we import it, we import the library up, and after importing it, we have to put the product optimization in it and help it maximize. And then we define decision variables and among other things. So this is a way to use linear programming to solve problem. And this brings end to our session today. Don't forget to check the sessions. Don't forget to check the references for more information, and also don't forget to submit your assignments and get back to us if you have a question. Tomorrow's session will be about assignment discussion. So come with your question and hopefully we'll be able to answer it. So let's watch our video for today.
It's actually pretty easy to imagine. Let's say you decide to visit a doctor because you're not feeling well. After diagnosing you, the doctor says that the best course of action for you to recover is to rest and take antibiotics. Well, prescriptive analytics works similarly, so let's get into it. Definition of prescriptive analytics. Prescriptive analytics is a type of data analytics that recommends a course of action users should take in order to achieve a desired outcome or goal. It comes after the stages of descriptive and predictive analytics. Focusing on actionable findings rather than data monitoring, prescriptive analytics does the following. First, it uses the data results from descriptive and predictive analytics to explore the outcomes of multiple scenarios comprised of varying series of actions, where each outcome is calculated based on the particular actions that were taken within that journey. These particular actions are typically reflected as variables, which are adjusted automatically and differently across each journey. Second, it then proposes the best journey or course of action out of multiple, selecting the one with the outcome that most closely matches the goal set beforehand. Prescriptive analytics works closely with descriptive and predictive analytics as it takes into account past, present, and future datasets to recommend a course of action or strategy. Basically, prescriptive analytics takes what we know, which is based on descriptive analytics, to forecast what could happen, which is based on predictive analytics, in order to recommend what to do, which is based on prescriptive analytics. Do remember, though, that the objective of prescriptive analytics is to help you achieve a goal that you have defined as a business or a company. In other words, the recommended best course of action is not necessarily the best in an objective sense, but it is the best in terms of how closely its outcome matches your predetermined goal. For example, these goals could be to double your profits, to shorten your product delivery periods, or to increase the number of students in your university. If we were to pick the first example, which is to double your profits, the prescriptive tool would predict multiple scenarios, each comprised of varying strings of action variables. In one scenario, these variables could be decreasing raw supply costs, increasing online marketing spend, and lowering product price points. If the outcome of this scenario leads to a 20% increase in profits over 5 years, whereas the outcome of another scenario results in a 40% increase, prescriptive analytics would propose the latter course of action to the user. Depending on the objectives set by the company, prescriptive analytics leverages combinations of different solutions to carry out its processes. In addition to the tools used for descriptive and predictive analytics, prescriptive analytics also uses mathematical programming, evolutionary computation, probabilistic models, simulation, logic-based models, and more. These are used to map out the different scenarios, the actions, and outcomes within them, as well as the best path to take. That's it for our definition of prescriptive analytics. Stay tuned to this series to learn about its examples and benefits next. To learn more about data analytics, visit us at www.cubeware.com. In addition to building end-to-end data analytics and BI solutions, CubeWare regularly curates educational articles on the most relevant components of the data analytics industry.
So thank you for attending the class today. And also, don't forget that tomorrow is our assignment discussion. And just for recap of what we did today. So today we looked at demonstrate prescriptive and analytic methods for finding best course of action for a situation. We looked at an example of a farmer and a product A and product B, to find the best form of action, and we concluded that linear, linear programming is the best to find the optimal production quantities for each product and maximize total profit. We also looked at classical optimization. We also looked at example of classical optimization, which involves linear programming, among other things. We also looked at techniques. We also evaluate prescriptive analytic techniques with appropriate example, which involves optimal model, decision trees, among other things. We looked at game theory, and we looked at an example of two products and all. So this brings to end our session today. Thank you for attending, and I hope to see you tomorrow for the assignment discussion. Bye-bye for now.